All right, let's get right into it. We're going to break down this really incredible piece of research from Yale that basically takes a golden rule in finance and data science and flips it completely on its head.
For decades, the answer to this question seemed like a total no-brainer. Of course it is. But what if all that conventional wisdom has been leading us down the wrong path? What if the real key to unlocking better predictions isn't simplicity at all, but actually embracing complexity?
To really appreciate just how radical this new idea is, we first have to understand the philosophy that's been driving how people build models for years and years.
In finance, and really in any field that uses data, the mantra has always been, keep it simple. Use as few variables or parameters as you possibly can. And the thinking behind it was solid. Simple models are tough, they're robust, and they protect you from making a really big, really costly mistake.
And that big mistake? It's called overfitting. It's what happens when your model gets way too complicated and starts to see patterns in the random noise of your old data. It basically becomes an expert on the past, which makes it completely useless for predicting the future.
Okay, so we've got the old way of thinking down. Now let's look at how this paper introduces a powerful paradox that pretty much questions everything we just talked about.
And there it is, straight from the source. What the authors are proving here is that simple models actually leave money on the table. They argue that the real predictive power is hiding in complex models that are so complex they actually have more variables than they have data points to learn from.
Just let that sink in for a second. This isn't some small adjustment to the theory. This is a complete paradigm shift. The very thing we were all taught to avoid at all costs, having more parameters than data, is now being called a virtue. But how on earth could that possibly work?
Well, the answer is in this really strange and counterintuitive phenomenon that researchers have started calling the double descent. Let's take a look at exactly what that means.
So imagine we're tracking a model's performance as we keep making it more and more complex. At first, just like we'd expect, adding more parameters makes the model worse. Its accuracy goes down. But then something truly bizarre happens. It hits a low point, and then it reverses course and starts getting better again.
Now what we're looking at here is that first part of the journey. As the complexity, which is that little c on the bottom, gets close to 1, meaning one parameter for every single data point, you can see the model's accuracy, or R-squared, just falls off a cliff. It absolutely tanks. This is that classic overfitting we talked about, kind of like the valley of despair for data scientists.
But here's the paradox. The moment you push past that point of maximum failure, when the model officially has more parameters than data, the accuracy curve starts to climb back up. This is the second descent. The model's performance actually improves with more complexity.
So what's going on here? Well, it's a phenomenon called benign overfit. Basically, when a model becomes ridiculously complex, it has almost infinite ways it can perfectly fit the training data. And the math shows that it ends up picking the smoothest or simplest of all those perfect solutions. The complexity itself almost forces the model to behave.
Okay, but wait a second. Look back at that performance curve. Even when the R-squared is getting better, it's still deep in negative territory. I mean, in statistical terms, that's a terrible model. So how could this possibly be valuable to an investor who's just trying to make money?
And right here, this is the money shot. This shows the actual investment performance measured by something called the Sharpe ratio. So while the statistical accuracy, that R-squared, was in the gutter, the economic value of the strategy is actually positive and climbing. It takes a little dip right around that scary c=1 point, but then it recovers and stays strong.
This brings us to the real core economic insight of the paper. When it comes to investing, it turns out that statistical perfection just isn't the goal.
So you gotta understand, we're talking about two totally different things here. R-squared, that's an academic measure of how good a forecast is. The Sharpe ratio, though, that measures your risk-adjusted return. It tells you, plain and simple, if a strategy is actually profitable.
So what the paper proves is that a model can be statistically wrong in its forecasts, that's the negative R-squared, but it can be directionally right enough to be a very, very profitable market timing tool. It gets the big swings right, even if it messes up the little details.
And just how profitable are we talking? The complex models in the paper pulled off an annual Sharpe ratio improvement of 0.47 over just a simple buy and hold strategy. Now, for anyone who's not in the world of professional investing, let me just tell you, that is a massive, massive edge.
So what does all this mean for the real world? for the future of artificial intelligence in finance.
Well, this wasn't just some abstract, theoretical exercise. The authors built these models using 15 totally standard economic predictors. And what's wild is that the models learned, all on their own, to be pretty cautious and mostly just stay invested in the market. But, and this is the kicker, they successfully pulled out of the market right before 14 of the last 15 US recessions.
And that's really the ultimate lesson here. The market is an unbelievably complex system. So instead of trying to force our models into a simple little box and risk missing the real picture, this research argues we should let our models be just as complex to better match that messy, unknown reality. It's a pretty powerful idea, right? And it leaves us with this one last provocative thought. If this belief we've held for so long about simplicity is wrong in a field as tough as finance, where else might our obsession with keeping it simple be holding us back?